Imagine the universe whispering its deepest secrets through invisible ripples in the fabric of space and time. Now, two groundbreaking discoveries are shaking up our understanding of black holes and the very laws of physics. But here's where it gets controversial. Could these cosmic smash-ups challenge everything Einstein ever taught us? Or are they just the tip of an iceberg hiding even wilder forces like hypothetical particles that might explain dark matter? Stick around, because what we're about to explore might just blow your mind. Just 10 years ago, in 2015, scientists first caught wind of gravitational waves, those elusive distortions in space-time caused by massive cosmic collisions. Since then, the LIGO-Virgo-KAGRA network, an international team of astronomers from around the globe, has spotted hundreds of these ripples emanating from clashes between incredibly dense objects like neutron stars and black holes. For beginners, think of gravitational waves as the universe's equivalent of sound waves, but for space-time itself, created when two heavyweights collide violently. Now, two new detections from October and November 2024 could mark a major turning point, revealing patterns that suggest our cosmos is filled with more surprises than we ever imagined. The first event, dubbed GW241011, was picked up on October 11, 2024. It involved two black holes smashing together, one weighing about 17 times the mass of our Sun and the other just 7 times. This all happened roughly 700 million light-years away, a distance so vast it boggles the mind, as light itself takes 700 million years to travel that far. But what really sets GW241011 apart is the spin of the larger black hole. Before the merger, it was whirling at a blistering 75% of the absolute fastest a black hole could theoretically spin. This rapid rotation challenges our models of how black holes form and evolve, hinting at a history of previous mergers that built them up over time. The second detection, GW241110, spotted just a month later, featured similar-sized black holes, around 16 and 8 solar masses. Again, the standout feature was the spin, but not its speed. Typically, black holes twirl in the same direction as their orbital dance around each other. In this case, though, the bigger one was spinning backward, opposite to its path. This is a first-time observation, and it forces us to rethink the chaotic environments where black holes pair up and collide. What makes these events even more intriguing is the idea that both larger black holes are second generation, meaning they're the offspring of earlier black hole mergers. The ones we detected last year were their parents, so to speak. This suggests that in crowded, dynamic cosmic neighborhoods, perhaps dense clusters of stars, or even the hearts of galaxies, black holes aren't lone wolves, but part of a bustling crowd where mergers happen repeatedly. For those new to this, picture it like a cosmic game of musical chairs where black holes keep pairing up and merging, growing bigger and more complex with each round. And this is the part most people miss. These repeated unions could be creating black holes that are far more massive and peculiar than we thought possible from single-star collapses alone. As Stephen Fairhurst, a professor at Cardiff University and spokesperson for the LIGO Scientific Collaboration, put it in a recent statement, GW241011 and GW241110 are among the most novel events among the several hundred that the LIGO-Virgo-KAGRA network has observed. With both events having one black hole, which is both significantly more massive than the other and rapidly spinning, they provide tantalizing evidence that these black holes were formed from previous black hole mergers. It's like piecing together a family tree of the cosmos, showing how black holes evolve through generations. Gianluca Gem, spokesperson for the Virgo Collaboration, added, "These detections highlight the extraordinary capabilities of our global gravitational wave observatories. The unusual spin configurations observed in GW241011 and GW241110 not only challenge our understanding of black hole formation, but also offer compelling evidence for hierarchical mergers in dense cosmic environments. They teach us that some black holes exist not just as isolated partners, but likely as members of a dense and dynamic crowd. These discoveries underscore the importance of international collaboration in unveiling the most elusive phenomena in the universe. In other words, teamwork across continents is what lets us eavesdrop on these universe-shaking events. To put this in perspective, we chatted with experts last month celebrating the decade since gravitational waves were first discovered. Professor Vicky Kalodjara from Northwestern University reminded us that the measurements we are making now remain the most precise measurements humans have ever achieved in any field of science and engineering. These two new events were analyzed with such incredible accuracy that the team could test not only Einstein's theory of general relativity, but also hunt for hints of exotic particles. On the particle physics front, they investigated the possible influence of ultralight bosons, hypothetical, featherweight particles that go beyond our standard model of physics, and might even make up dark matter, that mysterious stuff we know exists, but can't see. Thanks to these observations, scientists have now ruled out a wide range of possible boson masses, narrowing down the search for what dark matter could really be. For beginners, dark matter is like an invisible glue holding galaxies together, and bosons are just one wild idea for what it might consist of. When it came to general relativity, Einstein's groundbreaking theory explaining gravity as curvature in spacetime, the tests showed excellent agreement between predictions and what was observed. No signs of deviations that would shatter our current understanding. But here's where it gets controversial. Does this mean Einstein's theory is untouchable forever, or are we just not looking hard enough? Paper co-author Carl Johan Heister, an assistant professor of astrophysics at the University of Nevada, Las Vegas, explained, "This discovery also means that we're more sensitive than ever to any new physics that might lie beyond Einstein's theory. It might just take more events like these to uncover cracks in the foundation." A full paper detailing these findings has been published in the astrophysical journal Letters, inviting the scientific community, and curious minds everywhere, to dig deeper. So, what do you think? Do these black hole mergers prove that our universe is more interconnected and violent than we imagine, or could there be alternative explanations for their spins that don't involve repeated mergers? Is the hunt for beyond Einstein physics a thrilling frontier, or a fool's errand? Share your thoughts in the comments. Do you agree these discoveries challenge the status quo, or do you see them as confirmation of what we already know? Let's discuss.